The National Electrical Code, specifically Section 800.5, addresses access to electrical equipment. This section emphasizes that access to electrical equipment shall not be denied by an accumulation of wires and cables that prevents the removal of panels, including suspended ceiling panels. The core intent is to guarantee that all electrical equipment remains readily accessible for maintenance, repairs, and inspections. This accessibility is crucial for ensuring the safety and operational efficiency of electrical systems. The code recognizes that various obstructions can impede access to electrical equipment. These obstructions may include, but are not limited to, wires, cables, ducts, pipes, and other physical barriers. The presence of such obstructions can significantly hinder the ability to perform necessary tasks such as troubleshooting, repairs, and replacements. The specific scenario you describe involves a large and long AC duct positioned in front of a communication panel, leaving only a limited space of 1 foot by 2.5 feet for access. This situation presents a clear violation of the code because the AC duct obstructs free and unobstructed access to the communication panel. The restricted space makes it difficult, if not impossible, to effectively perform maintenance or repair work on the panel. To rectify this situation and comply with the code, you must take corrective action. There are two primary solutions to consider. Firstly, rerouting the AC duct, and secondly, installing a removable panel. Rerouting the AC duct involves physically relocating the ductwork to a different position that does not impede access to the communication panel. This may require careful planning and coordination to ensure that the rerouting does not create new obstructions or compromise the functionality of the AC system. It's also crucial to adhere to any applicable building codes or regulations that govern the installation of ductwork. Installing a removable panel involves creating an access point through or around the AC duct that allows for easy removal and replacement. This panel would provide a clear path to the communication panel, enabling maintenance and repair work to be performed without obstruction. The removable panel should be designed and constructed in accordance with relevant safety standards and should be securely fastened to prevent accidental dislodgement. In either case, it is essential to ensure that the chosen solution meets the requirements of the National Electrical Code and any other applicable local codes or regulations. Failure to comply with these codes can result in safety hazards, operational inefficiencies, and potential legal liabilities. Furthermore, it's important to maintain clear and unobstructed access to all electrical equipment at all times. This includes regularly inspecting and removing any accumulated wires, cables, or other debris that may obstruct access. By taking proactive measures to ensure accessibility, you can help to maintain a safe and efficient electrical system. Let's delve deeper into the specifics of electrical equipment access and clearance requirements, drawing upon relevant sections of the National Electrical Code and other industry standards. The NEC provides detailed guidelines for working space around electrical equipment, as outlined in Section 110.26. This section mandates that sufficient access and working space be provided and maintained around all electrical equipment to permit ready and safe operation and maintenance of such equipment. The depth of the working space and the direction of access to live parts must be at least 3 feet for equipment operating at 150 volts to ground, 3.5 feet for equipment operating at 151 volts to 600 volts, and 4 feet for equipment operating at 601 volts to 2500 volts. These dimensions are crucial for ensuring that electricians and other qualified personnel have adequate room to maneuver and perform their work safely. The width of the working space must be at least 30 inches, or the width of the equipment, whichever is greater. This width ensures that there is enough lateral space to accommodate personnel and tools. The height of the working space must be at least 6.5 feet, or the height of the equipment, whichever is greater. This height provides ample headroom to prevent bumping into overhead obstructions. The NEC also addresses the issue of dedicated equipment space in Section 110.26e. This section requires that the space above and below electrical equipment be kept clear of obstructions to allow for proper ventilation and maintenance. Specifically, the space above the equipment must be dedicated to the electrical installation, and no piping, ducts, or other foreign equipment can be installed in this space. Similarly, the space below the equipment must be kept clear of obstructions to allow for access to cable entry points and other components. In addition to the NEC, other industry standards and best practices provide further guidance on electrical equipment access and clearance requirements. The National Electrical Manufacturers Association, for example, publishes guidelines on the proper installation and maintenance of electrical equipment, including recommendations for working space and dedicated equipment space. These guidelines are based on years of experience and research and can be valuable resources for electrical contractors and engineers. It's also important to consider the specific requirements of the equipment manufacturer when determining access and clearance requirements. Some manufacturers may specify additional clearances or access restrictions to ensure the safe and reliable operation of their equipment. These requirements should be carefully reviewed and followed to avoid voiding warranties or compromising equipment performance. Now, let's turn our attention to the specific issue of AC duct obstructions and how to address them effectively. As you noted, a large and long AC duct positioned in front of a communication panel can significantly impede access and create a violation of the NEC. To resolve this issue, there are several options to consider. Firstly, rerouting the AC duct, and secondly, installing a removable panel, and thirdly, modifying the existing ductwork. Rerouting the AC duct involves physically relocating the ductwork to a different position that does not obstruct access to the communication panel. This may require careful planning and coordination to ensure that the rerouting does not create new obstructions or compromise the functionality of the AC system. It's also crucial to adhere to any applicable building codes or regulations that govern the installation of ductwork. Before rerouting the AC duct, it's important to conduct a thorough assessment of the existing ductwork and the surrounding area. This assessment should identify any potential challenges or constraints that may impact the rerouting process. For example, there may be structural elements, such as walls or beams, that need to be avoided. There may also be other utilities, such as plumbing or electrical conduits, that need to be taken into account. Once the assessment is complete, a detailed plan for rerouting the AC duct should be developed. This plan should include the proposed route of the ductwork, the materials and equipment needed, and the estimated cost and timeline for the project. The plan should also be reviewed and approved by a qualified engineer or contractor to ensure that it meets all applicable codes and standards. Installing a removable panel involves creating an access point through or around the AC duct that allows for easy removal and replacement. This panel would provide a clear path to the communication panel, enabling maintenance and repair work to be performed without obstruction. The removable panel should be designed and constructed in accordance with relevant safety standards and should be securely fastened to prevent accidental dislodgement. When selecting a removable panel, it's important to consider the size and shape of the opening that needs to be created. The panel should be large enough to provide adequate access to the communication panel, but not so large that it compromises the structural integrity of the surrounding ductwork. The panel should also be made of a durable material that can withstand the rigors of regular use. Modifying the existing ductwork involves altering the shape or configuration of the ductwork to create more space around the communication panel. This may involve cutting and reshaping the ductwork or adding new sections of ductwork. Modifying existing ductwork requires specialized skills and equipment and should only be performed by a qualified HVAC technician. Before modifying the ductwork, it's important to obtain the necessary permits and approvals from the local building department. The modification should also be designed and implemented in accordance with all applicable codes and standards. In addition to the above options, there may be other creative solutions that can be used to address AC duct obstructions. For example, it may be possible to install a smaller, more compact AC unit that takes up less space. It may also be possible to relocate the communication panel to a different location that is more accessible. Ultimately, the best solution will depend on the specific circumstances of the situation. It's important to carefully evaluate all of the options and choose the one that is most practical, cost-effective, and compliant with applicable codes and standards. In conclusion, maintaining clear and unobstructed access to electrical equipment is essential for ensuring the safety and operational efficiency of electrical systems. The National Electrical Code provides detailed guidelines for working space and dedicated equipment space around electrical equipment. When AC ducts or other obstructions impede access, it's important to take corrective action to comply with the code. Options for addressing AC duct obstructions include rerouting the ductwork, installing a removable panel, and modifying the existing ductwork. By taking proactive measures to ensure accessibility, you can help to maintain a safe and efficient electrical system. Remember that all electrical work should be performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. It's also important to obtain the necessary permits and approvals from the local building department before starting any electrical work. Safety should always be the top priority when working with electricity. Always de-energize equipment before performing any maintenance or repairs, and wear appropriate personal protective equipment. By following these guidelines, you can help to ensure a safe and productive work environment. Let's consider some real-world examples of how these principles apply in practice. Imagine a scenario where a large electrical panel is located in a cramped mechanical room. The panel is responsible for distributing power to various pieces of equipment throughout the building. Over time, the mechanical room has become cluttered with pipes, ducts, and other obstructions, making it difficult to access the electrical panel. In this situation, the building owner or manager would need to take steps to clear the obstructions and provide adequate working space around the electrical panel. This may involve rerouting pipes or ducts, relocating equipment, or simply clearing away accumulated debris. The goal is to create a safe and accessible work environment for electricians and other qualified personnel who need to service the panel. Another example might involve a situation where a suspended ceiling is installed in a commercial building. The ceiling conceals various electrical components such as lighting fixtures, wiring, and junction boxes. To access these components, it's necessary to remove the ceiling panels. However, the panels are often obstructed by wires, cables, and other items that have been placed above the ceiling. In this case, the building owner or manager would need to ensure that the wires and cables are properly routed and secured to prevent them from obstructing the ceiling panels. This may involve using cable trays, hangers, or other support structures to keep the wires and cables organized and out of the way. The goal is to allow for easy removal and replacement of the ceiling panels without damaging the wires or creating a safety hazard. Furthermore, consider a data center environment where numerous servers, networking equipment, and power distribution units are housed in close proximity. In such environments, maintaining proper access and clearance around electrical equipment is critical for ensuring the reliability and uptime of the data center. The NEC requires that dedicated equipment space be provided above and below electrical equipment to allow for proper ventilation and maintenance. This means that no piping, ducts, or other foreign equipment can be installed in these spaces. In addition, the NEC specifies minimum working clearances around electrical equipment to allow for safe operation and maintenance. These clearances must be maintained at all times, even when the data center is fully operational. To ensure compliance with these requirements, data center operators often use cable management systems such as cable trays and ladder racks to keep wires and cables organized and out of the way. They also implement strict policies regarding the placement of equipment and the storage of materials to prevent obstructions from forming. Let's discuss the importance of regular inspections and maintenance in maintaining electrical equipment access and clearance. Regular inspections can help to identify potential obstructions or hazards before they become a problem. These inspections should be conducted by qualified personnel who are familiar with the NEC and other applicable codes and standards. During the inspections, the personnel should look for any signs of damage, wear, or deterioration to the electrical equipment or the surrounding area. They should also check for any obstructions that may be impeding access to the equipment. If any problems are identified, they should be addressed promptly to prevent them from escalating into more serious issues. In addition to regular inspections, it's also important to perform routine maintenance on electrical equipment. This maintenance may include cleaning, lubricating, and testing various components. The maintenance should be performed according to the manufacturer's recommendations and should be documented in a maintenance log. By performing regular inspections and maintenance, you can help to ensure that electrical equipment remains in good working order and that access to the equipment is not obstructed. This can help to prevent costly repairs, reduce the risk of accidents, and improve the overall reliability of the electrical system. Remember, electrical safety is everyone's responsibility. By following the guidelines and best practices outlined in this discussion, you can help to create a safe and efficient work environment for yourself and others. If you have any questions or concerns about electrical safety, be sure to consult with a qualified electrician or electrical engineer.